Hey everybody, this is Tony Hawk, and this lesson will be on inference, which means the study of Z procedures for population proportion. Let's go ahead and begin. Draw an SRS of size n from a large population with unknown proportion p of successes. An approximate C level confidence level for p is, okay, we've seen this formula before, so it's p hat, which is our sample proportion, plus or minus our z-score. We find that in table C. And then p hat 1 minus p hat divided by n, square root all that stuff, okay? So to test the hypotheses, your null hypotheses that the population proportion equals p sub 0, we're going to commute the z statistics. And here it is right there. There's the formula for that. Okay, and then you'll see how it works in just a second. Okay, and if your null hypothesis is that your population is greater than your p sub 0, then we always do 1 minus table A. So now we're back to the z-score, so table A. Remember, table A is always to the left, so if we're doing greater than. And if we're doing less than, then it's just your table A number. And then if it's not equal to, then we got to do twice the table A. So whatever z is, the absolute value. I always like doing the negative one, you guys, because it's just a number over here. If we did this positive one, we'd have to do 1 minus that. So take the negative one and then just double it for that side over there. Okay, so they're symmetric. All right, so estimating risky behavior. So we're back to this National AIDS Behavior Survey found that the 170 of 2,673 adult heterosexuals had multiple partners. So the p hat is 0.0636 because they divided 170 divided by the 2673. And so we'll act as if this were an SRS, a simple random sample. So a 99% confidence interval for the proportion P of all adult heterosexuals with multiple partners uses the standard normal critical value because 99% confidence interval, if you looked on table C, my Z star would be 2.576. Okay, way down at the bottom. So the confidence interval goes like this. Okay, so there it is, my formula. And we just plug in those numbers right there. Okay, check them out, you guys. And then so, oops. Let's see. So I get this confidence interval right here. Okay, so there's my 99% confidence interval. Okay, so we're 99% confident that the percent of all adult heterosexuals who had more than one sexual partner in the past year lies somewhere between 5.1% and 7.6%, given that information they gave us with that sample. Okay, so binge drinking in college. So this example's on page 691. 1995 Harvard School of Public Health College alcohol study examined alcohol use among college students, including the practice called binge drinking. Binge drinking for men was defined as consuming 5 or more drinks on at least one occasion during the 2 weeks prior to the survey. 4 for drinks per women for the women drinkers. Okay, binge drinkers experienced a higher percentage of alcohol-related problems such as disciplinary problems, violence, irresponsible sexual activity, personal inquiry, and poor academic performance. Makes sense? It does to me. And in a representative sample of 140 colleges and 17,592 students, 7,741 students identified themselves as binge drinkers. Considering this an SRS of the 17,592 from the population of all U.S. college students, does this constitute strong enough evidence that more than 40% of all college students engage in binge drinking? Okay, so here we go. Step 1, we're going to identify the population of interest and the parameter you want to draw a conclusion about. State your hypotheses in words and symbols. So we want to test a claim about the proportion P of all U.S. college students who have engaged in binge drinking. And our hypotheses are, remember, it's no change, that it equals 40%. Okay, 40% of college students are binge drinkers. And the alternative is that it's greater than 40%. Okay, that's what we want to know. Is the evidence more than 40%? Okay, so the sample proportion of binge drinkers is the 0.44%. That's why they want to know, is it more than that? All right, so here we go. We're going to choose the appropriate inference procedure and verify the conditions for the selected procedure. So we're going to test the claim that the population proportion is greater than 40%. We'll use a 1 proportion z-test. Okay, so I'll show you how to do this in your calculators on the next lesson. Okay, so We're told that the survey designs, and you can just probably figure it out yourself, you guys. Survey designs allows us to consider the sample of 17,592 students of an SRS from the population of U.S. college students. There are certainly more than 10 times that many college students in the United States. There's millions of them. All right, so n times p sub 0. Okay, remember my p sub 0 is at 40%. That's my null hypotheses. And so we make that this equals the 7,036.8, and that's definitely greater than 10. And n times the complement, which is 60%, that's definitely greater than or equal to 10. So it looks like everything checks off and it's normal. So step 3, the conditions are met. We're going to do the z-test procedure. Okay, so there's our formula for that. Okay, remember, it's in your calculator. I'm going to let you guys figure that out. Otherwise, you have to wait till the next lesson. All right, so we get, there's my probability, 10.83. That's my z-score. It's not my probability, my z-score. Well, remember, table z goes, it goes up to 3.5, you guys, and that's just so darn large. You know, 3 point, imagine this curve. I wish I'd have drawn one. And imagine you got this curve right here, and over here's 3.5 right there. Well, my z-score is at 10.83. Excuse me. That's off the charts, you guys, so the probability is 0. So interpret your results. So the p-value tells us that there is virtually no chance of obtaining a sample proportion that's as far away from 0.4 as 0.44 is. Okay, so we're going to reject the null hypotheses and conclude that more than 40% of college students have engaged in binge drinking. All right, so is that coin fair? Example 12.7 on page 692 and 693. So coin is balanced, should come up heads half the time. So the French naturalist Count Buffon heroically tossed a coin 4,040 times. He got 2,048 heads, so the sample proportion is 0.5069. That's a bit more than half. Is this strong enough evidence that Buffon's coin was not balanced? So this one's going to be a not equal to. Okay, so this job is a significance test. So here we go. So identify the population. So population is coin tosses and the results, and the parameter is the number of heads, and what the proportion of all tosses given. The null hypotheses is going to be equal to 0, and the alternative is going to be not equal to 0. Okay, I thought it was not equal to 0 here, but this one says greater than 50. So I guess we're doing greater than 50%. All right. So it must be greater than. So first, let's check the conditions. Okay, the tosses can be considered an SRS, and the population of tosses is infinite, so it's definitely bigger than 10 times right there. All right, so carry out the selected procedure. Here we go. Crank it all out, and you get 0.88. So we look up z-score under 0.88, and remember, oh, it is not equal to. It is not equal to, so it's going to be twice that, you guys. So twice that score right there, and you get 37%. Okay, that is definitely not good enough to reject HO. So there's my z-score of negative 0.88 and positive 0.88, and so it was not equal to. Sorry about that. And so a proportion of heads as far as 1/2 of Buffon would happen 38% of the time when balancing the coin toss. Okay. So here is section E, a confidence interval on the coin toss. Okay, so 95% confidence interval would be this, and that's in your calculator too. I'm going to let you find that out. Okay, so then we crank that out right there, and we get that confidence interval right there, and that states that we are 95% confident that the probability of heads is somewhere between 0.49 or 49.15%, 52.23%. So it wouldn't even be surprising if we got, it's probably more like 51% they're saying right there. So we can't reject that null hypotheses. All right, so here we go. So here's section F, choosing a sample size. So to choose a sample size that yields a confidence level for a population proportion with a specific margin of error m, you solve the following inequality. Okay. And then so, if you're unsure about what proportion you're going to use, then always use 50%. So this would be 50%, this would be 50%, and it's not going to change your n size that much. So here's an example. How big should your election polls, how big should your sample be for to get a certain election won? So Gloria Chavez and Ronald Flynn are the candidates for the mayor of a large city. You're planning a sample survey to determine what % of voters plan to vote for Chavez. The population proportion is P. You will contact an SRS registered voters in the city. You want to estimate P with a 95% confidence and a margin of error that's no greater than 3%. So how large should your sample be, okay? All right, so the winner share in all but the most lopsided election is between 30 and 70% of the votes. So since we don't know what our p hat is, we're going to go ahead and guess at p at 0.5. Okay, so we're going to plug that into our formula. We want it to be less than our 3%, our margin of error. Okay, and then so we plug it in, and since it's a 95% confidence interval, my z star is the 1.960, which is in table n. When you cross multiply, we get that, and we get that. Don't forget to square it. Okay, and then since it's greater than or equal to, then it goes up to 1068 to satisfy that. Okay, and then this just talks about if you wanted a 2.5% margin of error instead of a 3-point margin of error, we plug in 0.025 right there, and we'd get 1537. If we wanted a 2%, we'd plug in 0.02. Okay, so to get a more accurate margin of error, you have to get more people involved. So as the percentages go down, then you get more people involved. All right,